In this lesson, we are going to talk about rotations, and many of our rotations will be on the coordinate plane. So I want to start us off with a definition of a rotation. So a rotation, it is a type of transformation, all of these are. So it is a transformation in which a figure is turned about a fixed point, which is called the center of rotation. So I know this word turn, sometimes in elementary school, this is how we describe rotations. It's a turn, but we'll use the word rotation anymore. So you will always have what's called the center. And I want you to take a look over here at this picture, over here to the side. So can you see how here, this, first of all, you have a triangle right here that is being rotated to the red triangle. So it has a center of rotation and it's down here. So oftentimes the center of rotation, it's not in the middle of the shape. It's hard to understand why it's the center because it's over to the side or below it. So when it talks about, for example, this is talking about a 40-degree angle. It's saying that if you were to sketch, let me get rid of some of this. If you were to draw, so actually, this whole shape right here, Q, R, and then this little flag. So let's look at point Q to point Q prime. So if you were to draw a segment and connect the pre-image to the center, and then the image to the center, and measure this opening, this right here is the 40-degree angle. Okay, so it's hard to see unless you draw that. The other thing that's true about rotations is this distance and this distance have to be the exact same from the center. So those segments will be congruent. So we're going to do something in class where we do some rotating on some tracing paper. But for this video, I don't have that shown for you. I do want to do this estimate right here. Normally we would use a ruler and protractor, but I just want you to sort of estimate what this would be. And so I want to do a little bit of drawing, and I might draw and then erase, and then sketch and erase. We'll kind of see what we get. Okay, so I'm going to try to rotate each point 120 degrees around point P. And so let's do a counterclockwise rotation. It's always assumed counterclockwise unless it's said otherwise. So what I want to do is take point A and rotate it 120 degrees counterclockwise. So I'm going to connect A to point P. Now, 120-degree rotation. So here's a 90-degree rotation. So, and of course, this over here would be 180. So I'm just going to pretend approximately this is 120, so a little more than 90. So what I want to do is if I look at my point, if I look at point P, if I were to look at P over to A as one side of my angle, and I'm trying to draw a 120-degree angle, like if I were to, oh my goodness, if I were to draw this segment, that's a 90-degree angle. So I want to draw something a little bit wider than that. So I actually want to draw, I don't know, about right like this. That kind of looks like a 120-degree angle. And I'm trying to make these segments approximately the same length. So I'm going to estimate that that's A prime, okay? And so I want to try to do that for the others. It won't be perfect, but it will give you that visual I'm wanting you to see. So let's take point B, and I'll try to use different colors. So from here to here is point B. View that as one side of your angle and try to estimate a 120-degree angle. So like, for example, that's approximately 90. Okay, so that is not what I want. So I want to try to make it a little bit bigger and try to be the same length. Okay, so that seems reasonable. Okay, so that looks like it's about the same as that. And then lastly, let's do C. So from P to point C, I don't know, this may not turn out to look like anything. So let's call that C prime. Tried to draw a prime, it didn't work out very well with C prime. And so if I make the triangle, that's actually not half bad. So can you see how, one thing to look at, do you see how point B has rotated? First of all, it's going counterclockwise. And so the opening of 120 degrees is hard to see right here. You really need to connect the pre-image to the center to see that. Okay, so we're not going to do a whole lot with rulers and protractors this year, but I just wanted you to get a kind of a visual in your head. Okay, so when we rotate, there are some specific coordinate rules, and this is the part we're going to do with an activity in class. But we can get a little bit of it here with this diagram over to the right here. So if we look at point AB, didn't mean to move that. If we look at AB right here, and if I want to do this 90-degree rotation, okay, so I'm going from, let me highlight just a little bit or outline. So I'm going to say that this in green represents a 90-degree counterclockwise rotation. Okay, so I'm going to add here 90 degree, I'm going to put CC for counterclockwise. Okay, so in green, hopefully you can see the 90, and I want you to see what happens with the coordinates. Okay, what we're trying to be told here is the original AB. Okay, so let's actually do an example through this whole thing. Let's call A +5 and let's call B +6. So if I do a 90-degree rotation, notice I'm over on the negative side of the x-axis. So notice how A is positive here, but the first point is negative. But I'm still in the positive region on both y's. So the way this is listed is my original B is 6. What this is saying is that number switches to the front and changes sign. So it just so happens to start positive, but it would switch to be negative. The A is the same as the original A, and no signs change. So what that means is my new ordered pair becomes -6, 5. Now, I usually like to do this with x's and y's. Okay, so here is my original xy. So when I am going counterclockwise, here's how I like to do it. When I'm going 90 degrees counterclockwise, the x and the y will always switch. So whatever the original x is, it sits in the second spot of the ordered pair of the original y. Since counterclockwise travels to the left on a clock, the number on the left is the one that changes sign. Okay, so I will try to repeat that quite a bit as we work through this. So back to the picture. Let's do the 100, let's skip down to 270. So 270 is going like from here all the way around like a quarter of a turn. So another way to describe that is to go back to the first point and go 90 degrees the other way. So this is also 90 clockwise. So 270 would be counterclockwise. It's also the same as 90 clockwise. So when I do my ordered pairs over here to the side, if I look here at this negative BA, so if I go back to the 5, 6, the B and the A are still switching. So 6 is going to switch to the front and not change, but the A is 5. When it says negative A, that means you want to change the sign. So when I go back to my X and Y, I always start this way. The Y and the X are going to change. 90 clockwise travels to the right, so the number in the ordered pair on the right switches sign. So that's how I handle 90. They both change YX, but one of them is negative in one part and one in the other. 270 is a little bit more straightforward. So look at 270 down here. The A and the B don't change location, but they just switch sign. So in my example I made up here, it would be -5, -6. So for 180 back to the X and Y, all that happens is the X changes to the opposite sign, and so does the Y. So you can use these shortcuts to get to your answer. You also could do this with slope, and so I might talk about that in class one day, but for this video I want to focus on the shortcuts. So the more we write them, the more we'll get them down. Okay, we've just got a couple examples where we are going to do some rotating. So graph the quadrilateral RSTU with the following vertices, then rotate the quadrilateral 270 degrees about the origin. So I'm going to go ahead and plot first. So 1, -1, 1, 2, 3, -1, 2, 3, 1, 2, 3, 4, 5. Oops, that's supposed to be negative. Okay, so this is R, S, T, U. Okay, now if I want to go 270 about the origin, I'm going to rephrase that to 90 clockwise. Okay, and so if we could write the shortcut like this, we could say the original XY will turn into, switch the Y and the X, but clockwise travels to the right, so the X is going to change sign. So I kind of like to write the new ordered pairs out. So if you want to write it like, like every pre-image compared to the image, you could organize it like this. You could go ahead and recopy out of the original problem the 4 ordered pairs. Okay, so I'll just show you this way on the first one. T is at 3, -5, and U is at 0, -4. So if I want to come up with R prime, I can come over here and say I'm going to switch Y and X, and then I'm going to make that new X negative. So that means the -1 comes first, but then the +1 here, I didn't mean to draw on that, the +1 will switch to -1 at the end. Okay, so let's do that for S prime. They switch spots, and so the Y does not change, but then when the X switches, it turns into the opposite sign, so negative. So for T, the Y doesn't change, it becomes the new X coordinate, but the 3 changes to the opposite sign. And then on U, the Y will become the new X, and of course 0 can't really change sign, so it'll just be -4, 0. So let's graph it, and then take a look. So, oh goodness, -1, -1, 1, or -1, -1, excuse me. And then -1, 1, 2, 3. And then 1, 2, 3, 4, 5, 1, 2, 3. And then 1, 2, 3, 4. Okay, so this is R prime, S prime, T prime, U prime. Okay. Now, to see the 90, I just want to point one part out. Okay, so let me get, I don't know, let me get orange here. So let's look at R and R prime. So if I were to connect a segment from the center of origin to R and the center of origin to R prime, can you see the 90 right there? So it makes a 90-degree rotation, and it is the same distance from the center of rotation. Okay, so if you want to, like these are the 4 ordered pairs. So if you didn't need to do a graph, you could, simply write those out. I tend to always use the shortcut and then I graph. I tend not to do it on the graph like I did for like translations or reflections. I tend to do the shortcut and then graph it. I let the graph be my visual to see if it looks correct. Okay, let's move on to the next one. If you want to do this one on your own, you can. I'll just keep talking through it and you can come back in and check your answer. So I'm going to plot my first quadrilateral. 0, 1, 2, 3, negative 5, 1, 2, 3, 4, 5, 6, and then negative 8, negative 2. So we've got A, B, C, D. Kind of looks like a parallelogram. It might be. Okay, so this time I'm just, now I want to, first of all, let's write our shortcut down. So if I'm doing a 180 rotation, for every XY, all I do is change the sign, but I don't switch them. So it's going to be negative X, negative Y. So I might just underneath, maybe I'll just write them underneath here if you have room. So A prime, I'm just going to change the sign. So it will change to positive 3, positive 1. Okay, B prime is going to stay 0, but switch to positive 5. C prime is going to now be positive 5, positive 6. And D prime will be positive 8, positive 2. So it should land over here in this quadrant because I'm going halfway around my graph. So notice they're all positive numbers, which makes sense. So 3, 1, 0, 5, 5, 6, and then 8, 2. Okay. Now I want to specifically make sure I label. So here is A prime, B prime, C prime, and D prime. So I want you to see I'm going to make the line between A and A prime. So if I go from A to the center of rotation and then I continue on to A prime, so it's going to look like a straight line, and I don't really need it to be counterclockwise or clockwise because it's the same answer either way. So this is one where I know the shortcut is easy, but you could count your slope out to get over there. Like what I mean by that is if I go up 1 over 3, up 1 over 3, see how I land on my image. So you could do your slope twice up to the center of rotation, and if you do it one more time, you'll hit that point. Okay, so again, that's just another example of preserving angle and preserving length. Okay, if you guys would do the last one and then come on back to the video and check. Oh, before you go, the 90 degrees about the origin, that is implied counterclockwise. So if it doesn't say, you assume counterclockwise. Okay, this is the same quadrilateral. Okay, I need to do for every XY. So they switch, and then counterclockwise travels to the right. Oh no, that's clockwise. Counterclockwise travels to the left, so the number on the left is negative. All right, so that means, let me try to put it underneath it if I can write small enough. So A prime means the X is going to switch to the second number, the Y comes to the first. So I switch the sign on the Y, but the X just switches location. So the Y comes to the front and changes sign. Of course, 0 just stays 0. For C, the Y comes to the front and changes sign, but the X just switches to the second number. Again, the Y changes to the front and switches sign, and then just keep the X the same. So 1, 1, 2, 3, 1, 2, 3, 4, 5, 0, 6, negative 5, and then 2, negative 8 is down here. So I have A prime, B prime, C prime, D prime. And again, I want to point the 90-degree out. So if we look at A to the center to A prime, there's that 90-degree angle, okay? So we can talk more about slope on these later if you want, but that is generally what we're looking at, okay? So bottom line, you need to become comfortable with these, and I would write them out on every problem. That way, the more you write them, the easier it will be to remember.